Okay, so the line of best fit is when you take a scatter plot that either has a positive linear or a negative linear association or correlation, and you draw a line right in between all the data. And that line is going to represent that graph. Okay, so as you can see, we have two examples here that are examples of the line of best fit. So examples of the line of best fit, write this down, are these two. Okay, they're examples of the line of best fit. And today we're going to be drawing the line of best fit. We're going to all draw our own line of best fit. And the thing is, it's not an exact science. My line of best fit will be different from yours. So my line may be different from yours, but they should be very close to each other. And I'll show you how to do that. Now, as you can see, this bottom one here, this is not an example of a line of best fit. Now, does everyone remember what an outlier is? Yeah. So if we have outliers in our data, so let's say we have an outlier point here, just like here. We exclude it, we ignore it. So basically in the notes, as you can see, it says exclude outliers. So if it's one of these oddball points that doesn't fit the pattern, you don't consider it when you're drawing your line of best fit. So say I have one there, or say I have one down here that's not part of the trend, you just exclude it. Don't even consider it, okay? Now, yesterday we learned, as you can see in this example here, that we can use our scatter plot, and now in our case, the line of best fit, to make a prediction. So it says how to use the line of best fit to make a conjecture or prediction at 21 degrees Celsius, which is about 70 degrees Fahrenheit, and total sales. So this is what they did, or this is what we're going to do. We're going to find where 21 degrees is. It's about here. And then you're going to go up to the line, then across, and see what value for sales, 480. So we're not going to be using the scatter plot this time. We're going to be using specifically the line to find the line of best, the conjecture.
Just a line.
Just the line this time. Okay. So let's try this. Number one, the graph represents about the yearly points scored by a certain race car driver. Okay, so here we have the years. So this would be 2005, 2010, 2015, etc. And it looks like it's more or less increasing. So we'll say it's linear and increasing. So the best way to do this is with your pencil. You want to kind of capture all your data as closely as you can. I'm going to make kind of like an amoeba looking thing, a blob, an oval in better cases. Okay? And now we're going to bisect it. We're going to cut it in half. Okay? So this is where our ruler, especially since it's clear, comes in handy. Okay? So I'm going to say, oh, okay. I want to have maybe as many points on one side as the other. So I have 1, 2, 3, 4, 5, 6 above, and 1, 2, 3, 4, 5 below. So somewhere about there, where you cut it in half, and then you draw your line. Okay. So here's my line of best fit. Okay. All right. And now we're going to do this. Use the line of best fit to make a conjecture or prediction about the points the driver will score in 2015. So since this is 1999, it's kind of going perfectly so that 15 is 2015. Just worked out nicely that way. Okay, so we're going to go to 2015 or 15 and go. I'm going to go until I hit the line. And then I'll go across. So it hits right about there, more or less. This is not an exact science.
That's like 6,500. 7,000.
Well, let's see.
It's in the middle.
1,000, 2,000, 3,000, 4,000. The thing is, I think it's about 7,000. Yeah, because 6,000 is here. That's 7,000. 8,000 would be above it.
What about the middle?
Yeah, my line isn't perfectly. I'm going to say about 7,000. And about.
Why not 6,500?
Because it's each of these. So this is 1,000 right here, right? They didn't put it perfectly on it. So it's kind of an error on their part. I would have been better if they put the 1,000 right next to it, but they didn't. But this is 1,000, 2,000. So the one below is the one that's the number above.
My one says
Okay, so it's about 7,000 points. Okay,
this is just a prediction.
it's a prediction. All right, any questions? And yours may be a little different. If your line's slightly different from mine, maybe it is 6,500. If you're in between either of the marks. It just depends. But you should be close to me.
Like rounding up.
There's a close answer. Yeah. On this, it's imprecise because we don't all have the same exact line. All right. Let's move on to example number 2. Okay. Example number 2. So here we're going to actually we're going to plot some points and make our own scatter plot, then draw the line of best fit. Okay? So let's read what example number 2 says. It says, Selena's having a surprise party for her friend Ernie. The table shows how many balloons she has been able to blow up by the end of each 10-minute segment. So as you can see, we're measuring by minutes on the x-axis. We're measuring by the number of balloons on the y-axis. And they're giving us a table of data. And we're going to plot those points. So this is going to be x, our time, and this is going to be y, the number of balloons. So let's see. At 10 minutes, there were 3 balloons. So we have to kind of estimate. Looks like it's going up by 4. So 3 would be right below that. So that's going to be 3, more or less. At 20 minutes, we had 12 balloons. So that's perfectly on the cross marks. Okay. Then we had 30 minutes, 15 balloons. So 16, we're going to go right below 16 for 15. And then we have 40 minutes, 16 balloons. So only 1 balloon extra was blown up by then. Okay. And then 50, we had 21. So 50, there's 20 right above it. Ran out of breath, had to go do something. Any number of factors. Okay, so as you can see, what kind of association is this? Positive, negative? Positive, it looks to be linear. So it looks like we can draw a line of best fit. So let's see here.
You on the side and you have five.
Yeah, something like that. So something more or less like this, maybe. And we want to just make a line. Now, clearly at 0 minutes, there were 0 balloons, so that could be considered another data point. So something like that. Kind of weaving and bobbing between points. Maybe yours is a little different from mine, but it should be close. All right. So we did part A. We plotted the points, we constructed our line. Now we're going to use our line to make a conjecture. Use the line of best fit to make a conjecture about the number of balloons she will have blown up at the end of 70 minutes. So here's 70 minutes. We're going to draw a line going up. We're going to just mark all the way up to the line.
There it is.
So it's between 32 and 34 for me. So I'm going to say about 33 balloons.
Same. I say 33 balloons. I say 33 balloons. I agree.
And hopefully yours are close to that. Maybe you had 32, maybe you had 34. But in that neighborhood. Okay, so for the next part, we are going to be using the calculator.
Interesting.
Okay, any questions? So we have 2 more examples to do, example 3 and example 4. And in these 2 examples, they're going to have a line of best fit already made for us.
Yeah.
But we're going to come up with an equation. But we already know how it should look. Y equals mx plus b. So we're going to have to figure out a slope, figure out a y-intercept, so we can write an equation. Okay? All right. Let's move on to example 3. Okay, so we have a scatter plot this time that shows the graduation rate of high school students. All right, so here we are. Since 1998, that was year 0. So if we add 1 to that, that would be 99. If we add 2 to that, that would be 2000. Okay? So this is 2000, 2001, 2003, 2004, etc. Okay? So right here at 10, that's 2008.
Wow.
Yeah. Right there. So this is some actual data that they were looking at graduation rates overall in the country. Okay, write an equation in slope-intercept form for the line of best fit that is drawn. Okay, so slope-intercept form. That tells me y equals mx plus b. Okay, so we're back to what we were doing last semester. We're writing equations. We need 2 pieces of information, right? We need a slope, and we need the b, the y-intercept. The y-intercept's easy to find. Just look along your line and go to the y-axis. Where is our line crossing the y-axis? At what number? 60. So that means the graduation rate started at 60%. So I'm going to write that down. 60% graduation rate. But luckily it's increasing. Okay? Now we have to find the slope. So we have to find 2 good points. Well, 60 is a good point. You see it? It's a good point to start at. We're going to do rise over run. Okay? And if I'm looking, looks like this is a good point at 465. That's another. So we're going to do rise over run with those 2 points, 060 and 465. So we're going to go up one step. Okay. So how much did we go up? 5. So we went up 5%. And then how much are we moving across? 4. 4 years. Yeah. So it's going to be 5 over 4. Okay. 5 over 4. Okay. So we have our equation now. The equation we're going to use is y equals 5/4 x plus 60. Okay. So we did rise, we did run, we came up with 5/4. Okay. Part B. We're going to interpret the slope and the y-intercept. What do they mean based on what our data is about? Okay. So let's see. Let's start with the slope. Slope. It's 5 over 4. Okay. What are we measuring on the y-axis?
Number of years.
Yeah, graduation rate in percent. So basically, it's going up 5%. So this is 5%. What are we measuring on the x-axis for the run, for the bottom number?
Years.
Years. So basically, we can say the graduation rate was increasing 5% every 4 years. Every 4 years. Now, if we divide 5/4, that's 1.25. So it was going up 1.25% every year. Okay, but it's 5% every 4 years. Okay, y-intercept. Let's talk about the y-intercept. It's this number here, 60. Basically where we started. Started at 60%. So we can say we started at 60%. So we started at 60%, we're going up 5% every 4 years. Okay, more or less. Cool. So now, use the equation to make a conjecture about the graduation rate in 2020. Okay. Well, we got to figure out, that's an x value. Now, if 10 years is 2008, if 10 years is 2008, how many, at what number here will we have the year 2020? 12 years later. It's going to be 12 years later. So what number would that be here? You have 10 and you add 12. What do you get?
22.
22. So we want basically when x is 22. When this x is, if we could extend this graph all the way to like 22 and follow the line, we would have it that way. But now we're going to use the equation because you don't always have the graph to go by. You have to use the equation. Now the equation is y equals 5/4 x plus 60. Okay? So what we're going to do is we're going to plug in some numbers and then we're going to figure it out on the calculator. So we're going to have 5/4, but put it in parentheses, 5 over 4 in parentheses. Then we're going to replace x with 22. So that means times. Remember, parentheses next to each other means to multiply. And then we're going to add 60. So this is what we're going to enter into our calculator. In parentheses, 5/4. In parentheses, 22 right next to it, plus 60. So let's do that. So on the calculator, we're going to put open parentheses. That's this button right here. So you want to put this button. Then 5 divide 4. Oops. So turn it on, clear it. If you need to, you might have to clear it.
And then another parentheses.
5 divide 4. You should have 5/4. Close the parentheses. Then open another parenthesis. And then you're going to do 22. And then you're going to go close the parentheses plus 60. And it'll do the whole calculation for you.
Yeah.
What is the area?
78.
What is it?
87.5. So in the year 2000, it should be 87.5%.
Next.
Okay, so if you did the math correctly, parentheses, 5/4, close parentheses, 22, close parentheses, plus 60, press equals or enter, you'll get 87.5, which is a percent in this case. And this is how they make predictions for stuff. Rarely do they use the graph. It's the equation you get from the graph that you could use. Okay? Any questions? We have one more. You guys ready? Okay. Here's the last one. It's going to be more practice on the same thing. So this one has a negative correlation. It's a linear negative correlation. And they drew the line for us. It says the graph shows the average annual temperature at different elevations. So as you can see here, we're measuring elevation, the height, in meters. So a meter is about this much longer than my arm span. 1 meter, about this much longer than my arm span. So we're talking about 500 meters, 1,000, 1,500, etc.
That's a lot.
Yeah. And what's happening to the higher up you go, what's happening to the annual temperature?
It's going up by 5. I'm down by 5.
It's going down by 5, it's dropping. And that, it makes sense. The higher up you go, it's colder. That's why right now when we get snow up in Big Bear, they get, here we get rain. Up in Big Bear, they get snow because of this fact.
The higher limits.
Oh, yeah. Okay. So first thing they want us to do is write the equation in slope-intercept form. So we want y equals mx plus b. Okay, so easiest thing to find is the y-intercept. So it's between 20 and 25. What would that be?
20.
What's halfway between 20 and 25? 22.5.
22.
Yeah, so that's going to be 22.5 degrees. Now remember, that's degrees Celsius. So if you're at sea level, wherever this is, if you're at sea level,
If you go higher than
22.5 degrees, how much is that, do you think? Oh no, very comfortable. Remember, it's degrees Celsius, not Fahrenheit. It's about 70 degrees. Maybe even, it's about 75 degrees actually. Maybe even a little better. So that's not bad. Yay. But the higher up you go, it's going to get colder than that on average. Okay. Okay, the slope. Slope's going to be a little trickier, but not impossible. So let's figure out the slope. All right. So let's figuring out the slope. We're going to do this point here, and maybe to this point here. You see the points I'm selecting? Those look like good integral points. So we're going to select those. And we're going to do rise over run. Okay, so we're going to go down 2 steps.
Why two?
Well, because we want to get across to this point. That's a good question. Why 2? We want to go down and across. So we want to get to this point, we only have to go down 2 spots. And then we're going to go across 3 spots. Okay? So we're going to go down 2 spots. So if I went down 2 spots, how much is that?
Like
Every 2 spots is how much?
5.
5. So it's down 5. So it's down 5 degrees. And then we're going to go across.
3 times.
Yeah, how much is that?
5.
So let's see, every 2 is 500. So you're going to add another 250. So 0. This is 250. This is 500. This is 750. And that's 750 meters. So let me write that down. -5 over 750. So that means the temperature drops 5 degrees every 750 meters. But since they're both divisible by 5, let's reduce that. Yeah. So -5 divided by 5 is -1. And what's 750 divided by 5? Divide 750 by 5, please. How much is that?
150.
150. So that means temperature drops 1 degree Celsius every 150 meters. Okay? And that's basically what they're asking us here. Interpret the slope. -1 degree Celsius over 150 meters. And the way I get that is I look at what I'm measuring on the y-axis, that's degrees Celsius. I look at what I'm measuring on the x-axis, that's meters. So it's going down 1 degree every 150 meters. Okay, and what's our y-intercept? 225. Or, I'm sorry, 22.5. So at 0 meters, at 0 meters, right on the beach, it's 22.5 Celsius. So at 0 meters, it is 22.5 degrees Celsius. Okay? All right. So now we're going to use our equation. Here we go. Oh, we haven't written our equation. Let's write it. Y equals -1 over 150 x plus 22.5. This is why we have a calculator. This is our equation. Our slope, x plus y-intercept 22.5. Okay. And now they tell us Mount Whitney here in California is the tallest mountain in the continuous United States. That means not including Alaska or Hawaii. There's a mountain in Alaska that's much higher. It's higher than this. Its peak is at 4,421 meters. That's way up there. Make a conjecture about what would be the annual temperature at the top of Mount Whitney. So basically, they're telling us X is 4,421. X is 4,421. Okay, and we're going to plug that into our equation. Y equals negative 1 over 150 X plus 22.5. Okay, so this is what we're going to enter into the calculator. Ready? Parentheses, negative 1 slash 150, close parentheses, open up new parentheses, 4421, because that's what we are replacing X with, and then close the parentheses, plus 22.5. Now, does everyone see where I'm pointing, this button here, with the parentheses and the minus sign? That's how you get a negative. You don't use the minus sign for a negative, you use this button here. Okay? So let's go ahead and try that. So on the old calculator, I'll clear it. Parentheses, then that negative button I showed you, 1 slash 150 or divide 150. So it should look like that. Then close the parentheses, open new ones, 4421. Yeah. Plus 22.5. Oops. I got to go delete one of those twos. I'm going to hit the delete button. Okay, so if you did it correctly, negative 6.9. So about negative 7 degrees. Negative 7 degrees. That's cold. On average, you know, in the winter it's probably colder. Summer may be a little warmer. But on average, that's the temperature. So let's write that down. About negative 7 degrees. About negative 7. I rounded it. Yeah. All right, so we're going to be practicing this.
Yay. On our computer? No.
I got a sheet.
Darn it. Doesn't that part?
No.
I'm gonna